Okay, this is quiz number 6, problem number 1 on the green form of the quiz. So we want to, using this function on the domain from -2 to 2, closed, we want to locate all extrema and give all relevant information. So at this point, if you're not taking a derivative, you're doing something wrong. So we get the derivative here is 6t squared plus 6t. Now what do we do with that derivative? Well, we're finding extrema. Good thing to do, set it equal to 0. And well, we want to solve that. So my favorite way is factor out 6t. So you got 6t times t plus 1 equals 0. That means either 6t equals 0 or t plus 1 equals 0. Alright, so here solving this gives you t equals -1, and over here you get t equals 0. Alright, so these are our critical points. Where else can an extrema occur? Singular point, polynomial, we don't get singular points on polynomials, and at our endpoints. So we also want to check t equals 2, t equals -2. Alright, so we've got these points, or we've got these t values. We want to make a list of points. So from -2 goes next to -1, to 0, to +2. Alright, well, we want to get our output values here. We're going to do that using our original function. Okay, so use the derivative to locate our critical points, but our y values still come from our original function. So okay, so when we plug these in, we'll get -4, and down here we'll get +28. Right? If you want to know where those came from, here's the calculator. Just plug it in again to the original equation. If you want to take a closer look at that, just press pause. Alright, at 0, well, you plug in 0, you're going to get 0, but only because 0 plus 0 is 0. Plug in 1, you get 2 plus 3. It's going to give you a +5. Alright. Okay. So next question is, which of these are maximums, which ones are minimums, where's your absolute, where's your relative? Well, we have the extreme value theorem, which tells us that if we have a closed domain, which is exactly what we have, our domain is a closed interval, and we've got a continuous function, it's a nice polynomial, then, well, we're going to achieve our maximum, absolute max, and absolute minimum, and those points will actually be our largest and smallest numbers in here, smallest being most negative. So I look at this, I've only got one negative number, so this is going to be my smallest number right here. I've got an absolute minimum at -2, -4. And here my largest number is 28, so that's got to be my absolute maximum. Absolute max. Alright, these other two, well, I don't know. So I know that if these are actually extrema, my minimum will have to be followed by a maximum, then minimum, then maximum. But these could be not extreme. These could just be weird inflection point type things. And in which case, we're going to get, these will be not extrema, and we still go from min to max, and that would be fine. So we have to check. So I'm going to use the second derivative test, because I think we need a little more practice with that. So f double prime of x. So second derivative test, we need to take second derivative. First derivative is this guy. So derivative of the first derivative is 12t plus 6. That gives us our second derivative. So f double prime of -1 and f double prime of 0. So I'm going to plug in my critical values here, -1 and 0. So I get -12 plus 6 is -6, and 0 plus 6 will be just +6. Alright. Great. So this is negative, this is positive. Negative is a frowny face, positive is a happy face. So this tells me my concavity at these points. So negative means if I had an extrema, it's got to be up here at the top. Positive means if I have an extrema, it's got to be here at the bottom. So here my second derivative was negative. This means I got a relative max. Here my second derivative was positive. I've got a relative minimum. Okay. And I know they're relative because I've already found my absolute. They can't be absolute. Alright. So there's all the information I was looking for. Found all my minimums, maximums. I know whether they're absolute or relative, and I know the xy coordinate of them.